everybody, I'm Michelle and this is the violet weather demonstration. To start off, we have weather because we have an atmosphere. That is the layer of clouds and air surrounding our planet. Anything that has to do with the atmosphere would be considered weather. Now that that's done, let's talk about weather. So, weather can be broken up into key ingredients. Just like making a cake is made out of ingredients, weather is made out of ingredients as well. One of those first ingredients is air, okay? Or specifically, air pressure. So, to show you air pressure, which is, you can think of air pressure as the amount of air in one area at a given time, we can do a very simple demonstration involving a cup, a plate, some water, and I recommend a bowl. What we're going to do, this cup is currently full of air. We're going to replace some of that air with water. Alright. And I'm now going to trap that air in between the cup and this plate. Now what I've just done, the air inside this glass, there's much less than compared to outside in this room, which means I have what we call low air pressure inside the cup and high air pressure in the air around us. Air likes to move from areas of high air pressure to areas of low air pressure. It's trying to equalize things. That movement of air from one pressure system to another is how you get wind. In this case, the high air pressure in the room around us is trying to get into this glass. There is, however, a plate in the way. So what's actually happening is the air in this room is holding the plate against the glass. And it's going to continue to do this as long as there is that difference in air pressure. The second I allow something to equalize, say opening up a gap in here for the air to get in, there's no longer that difference in air pressure and the plate falls. It's the same reason that suction cups actually work. When you stick a suction cup against a surface and squeeze, you are removing air from in between the suction cup and whatever you stuck it against, meaning there is low air pressure there, and the high air pressure of the room is going to force it down and hold it in place. Air pressure can be a pretty strong thing. To show you just how strong air pressure can be, I've had a setup happening over here. I have here a soda can that had a little bit of water in it that I have been heating up. Now the reason I've been heating up the water in this can is to actually heat the air inside the can up. When air gets warm, it expands and rises, so the air in this can is trying to escape out of the can. And what I'm going to do is I'm going to take the can and turn it over, opening side down into the water. What will happen when I do that? The air inside, the hot air, is still going to try to escape out of the opening, but there's not going to be any air left to enter, which means I will have low air pressure inside the can, and the higher air pressure of this room, well, I'll show you. It'll crush the can. All right. So, air pressure is one factor in weather. Speaking of, we're going to move over here because that warm air inside was expanding and it was also rising up. Warm air will rise up. It's less dense than cold air. So it'll rise up to the upper reaches of the atmosphere. This is actually how something like a hot air balloon works. In a hot air balloon, the air inside the balloon heats up, it expands, and it'll start to lift up into the air. This is going to be a bit loud and hard to hear me, so just be patient. We have to wait until the whole balloon fills. So that's hot air. We also have to be aware of what cold air does, however. Cold air does the opposite. If hot air expands and rises, cold air will condense or take up less space, and it'll also drop down to the bottom. To demonstrate this balloon is full of air, and I'm about to make this balloon very cold, making the air inside the balloon just as cold. To do so first, I'm actually going to need something called liquid nitrogen. Nitrogen is a gas found in the atmosphere around us. When cold enough, and by cold enough I mean negative 320 degrees Fahrenheit, it turns into a liquid. To the balloon when I make the air inside cold. You'll notice it's condensing and it's taking up less space. This makes it more dense than warm air and causes it to sink down to the bottom. So not only is wind caused by differences in air pressure, it is caused by differences in air temperature as well. Once the air warms back up, it'll expand and rise once again. Bye, balloon. Okay. Now, air moving due to differences in temperature, hot air rising, cold air dropping, can also lead to some more extreme versions of weather, like the tornado. A tornado forms when you have rising hot air rising up, cold air is dropping in the middle, and then there is a wind direction that is coming in at a horizontal angle, and this causes everything to start spinning. And if you get it spinning fast enough, well, you have a tornado. Okay. Now, it's kind of hard to see how the wind is reacting in such a small bottle. So I'm going to take you over to our spinny tornado chair to demonstrate using, well, me. Alright, I am now on the spinny chair. I'm going to demonstrate how the wind in a tornado is going to be moving. I have these weights here. It's just going to help me with my spin. And here we go. Alright, with my arms straight out like this, I am mimicking the air on the outside of the tornado, which is the warm rising air. As you notice, it seems to be spinning slower. In like this, it appears that I am spinning faster. This is the cold air inside the tornado dropping and spinning at a much faster speed. This is what lends to that funnel shape that tornadoes are so famous for. Alright, so we talked about some extreme weather. We've gone over 2 of the 3 ingredients for weather. We have talked about air, pressure, and we have talked about temperature. The last ingredient is water. Okay, now, one way to think of the air around us is that it is a giant sponge. Air is a sponge. It'll soak up water vapor. This is what we call humidity. If you've ever heard someone say, oh, it's really humid out, this is when you walk outside in the middle of summer and it's so hot and muggy, you feel almost immediately sweaty. That is a lot of high humidity. There's a lot of water in the atmosphere. Winter, we have dry humidity. There's not a lot of moisture in the air. It's why our skin gets really cracked in the winter time. Now, air, as it's moving due to wind, will carry moisture with it. That hot air rising will carry water vapor up to the top of the atmosphere with it. Now, the further away from the Earth you go, the closer to the top of the atmosphere you get, the colder it gets. So that rising hot air will eventually cool, and so will the water vapor inside. And the water vapor will condense as little water droplets. Those water droplets will stick to each other, or they'll stick to pieces of ice or dust or dirt in the atmosphere or smoke, and that's how you form clouds. So we're going to form a cloud indoors right now. We're going to make it in this little container right here. I'm going to start first with some warm water. This warm water is going to give us the warm rising moisture-filled air that we'll need for our tornado. There we go. This is going to act as our cold atmosphere. Now I need to make it colder, so I'm going to pour the remains of the liquid nitrogen in. This is going to make us a nice cold atmosphere. And then to make our cloud, we need something for the water droplets to stick to, so I'm going to add some smoke from a match inside. Okay. Now I will have a cloud forming inside this jar. This cloud, I should tell everybody, it's not going to look like the clouds up in the sky. It'll be together in this jar for a couple of seconds, and then eventually the warm air is going to start rising out and it's going to dissipate the cloud. So pay attention to our cloud when I lift this up. You guys ready? And here's our cloud. So this is what's happening up in our atmosphere. It's just the cloud tends to stick together a lot better up there. And of course, like a sponge, a cloud can only hold so much water. Eventually, it's going to get to the point where it can't absorb any more water. And that water is going to come down as some form of precipitation. Rain, snow, sleet, hail. The type of precipitation will depend on the temperature of the air around it. If it's cold, you're going to get snow and ice. If it's warm, you're going to get rain. All right, now those water droplets up there in the sky aren't just forming clouds, they're rubbing against each other. And they're building up a charge, an electrical charge. And when you build up enough of an electrical charge, you get lightning. This is our Tesla coil. It's going to give us some lightning indoors. All right. So, I'm first going to plug it in. And then I'm going to make sure I am on the other end right over here. All right, now for our Tesla coil, I'm going to start by turning everything on. I'm going to turn off the lights, count down from 3, and we should see some indoor lightning. Is everybody ready? 3, 2, 1. I should let you guys know that was a test to make sure you were super ready for this. I'm about to do it for real. And in 3, 2, 1, lightning. All right. So, what we just saw was the lightning discharging, and that's actually what happens with lightning up in the clouds. The clouds build up not so much of a charge, negative or positive, usually negative because it's forming a lot of electricity up there. And that electricity wants somewhere to go. So it's going to reach out and it's going to reach for the most oppositely charged or the most grounded object nearby. In case of lightning storms, that grounded object it reaches for just so happens to be the ground, and that's why lightning tends to shoot down towards us. Alright? But that is our violent weather demonstration. I hope everybody has learned something new or interesting about it. So next time it rains or storms, you know what's happening. Thanks for joining us today. Bye.